Okay, we have some success here. I was able to print these parts. I used the average setting, the good setting, and the parts came out good. I changed it a little bit. And what I did was I tried to eliminate anywhere where there's a blind hole. I made the holes go all the way through if they weren't important, or if it didn't matter, I put the holes all the way through so I wouldn't have these standoffs going in there. And it worked out really well. Now this is the one side where the motor goes into. This is the other side. And then this is the piece that goes here. So what I did was, this is where the belt goes to drive this way. And on top of here, it would have been all filler material. So I sectioned that off and I made a separate part here. This part gets put onto that part. And I took this square bore, which was clearance, and I just put it all the way through the part. It goes all the way through. It was really, at first it was 1/2 inch deep, but then it would have been all filler material inside, this and that. And what I'm trying to do is I'm trying to increase trying to decrease the print time and decrease the amount of filler material that has to be put into this part. Now see this one here, I could have made that all the way through. That's where the back of the belt is, but I missed that one. But nevertheless, the quality of the part looks a lot better. And as far as the flatness is concerned, now this is not a raft. It looks like a raft, but it's not a raft. So what I ended up doing was the part, I don't know how I can explain this. Oh, let's see what we got here. Okay, the part, this is the center of the part. And it looks something like this. So the part has to be split in the middle to put the components in. So this part here And this part is actually this part, this side. So I cut it here because the belt rides on these pulleys here with the motor in the back. The motor sits on this side, goes through, drives that belt. Then you got that idler pulley that goes through here, and the belt comes around here and drives this piece back and forth. So I was able to solve this problem without making a raft is that this piece is actually part of the part. When I trim this piece off, I don't break this piece away. This piece is the part. So what I got to do is I got to cut it here, cut it on the outside of this part, because what I did was I took this and I says, well, at first, two of these are 30 thousandths thick, and this was the first one I printed. I printed the one with the less amount of hours to see if it would work, because if something happened, I have the least amount of hours into it. So this is 60 thousandths thick. So what I do is I took the part and actually made a split line here. So these are, well, this one here is this one, but we'll talk about this one, which is this one and this one. So instead of splitting apart in the middle, I kicked it over 0.30. I made that the split line. Now when I got the part separated, I took that part then in the 3D software I added that 30 thousandths, plus I made it a lot bigger. So this part is actually goes to the center. But I made it bigger so that it would have more surface area to be on the table so it wouldn't warp. And it came out really good. I mean, it's flat. And the inside here didn't warp either. That's flat. So everything worked out great. Then what I did, this was the first one, so I took the distance from here to here and I cut it 60 thousandths, because I was thinking, you know, a 1/16 of an inch thickness there, which is equal to what a raft, what the machine puts down as a raft. So I made that 60 thousandths. Then when I separated this part, I added that 60 thousandths to it, and I made it bigger. So if I just cut it here, then trim it around there, that is the distance from the inside to the center, or from here to the center, is the same. so the part is the same. So like I said, I moved it over well, this one's 60, then I added the 60 when the part was separated. So it's still the same distance from here to here, is still the same. And from the center to here is still the same. So I'm using the part as the material to lay down on the plate. And that worked out really well. So so the first one, like I said, was 60 thousandths, and I realized I didn't need that much material bolting down to the plate. So I made the other ones 30 thousandths. That worked out really well. Nice and flat. I spend less time building this raft. Well, I'll call it a raft, but it's not, but it's actually part of the part. I made the part thicker, but it's still the part. So all I have to do is just cut this excess material away, and I'll be good. So that's what I'm going to do next. But that worked out really well. So I think that'll give me something to, now I'll be able to mount the motors in there and put the gears in it, and at least give me a mock-up of what I'm looking at here. I had to make this big so I could put the motor in there, but I still needed this thread here because the block on the outside is going to mount to those tapered bearings. That's what's going to make this thing rotate. So I had a little 45 in there to give those threaded holes a little more meat. And this is slotted because that's the only way you can get the motor in there. You have to bring it in from the bottom and you got to put it in there. Then it mounts through those 4 holes. And this is where the end of the pulley, there's a pulley. Well, this one's the same way. But that's where the pulley's going to be. Right here. That goes through, and that's what that bearing material is for. But there was another thing with the belt. The belt's going to ride up here. The belt's going to ride up here. Now the thing is that the belt, this belt's made out of rubber, and it doesn't like to slide on anything. This has got to be able to slide really well. So what I thought I'd do is these hole in here, these grooves, I'm making a air bearing to go in here. So the belt is going to ride. There's going to be a piece of material in here that the belt is going to sit against, and it's going to ride on this air bearing, and that'll, because there's really no way you could put any kind of bearing material in here, or, well, I'm sure there is a way, but it would be really complicated. So that was my thought. there's going to be a cap that goes over here that captures all these air passages. Then there's going to be some material here. Then the belt rides on that. And where the pulley is here, these little holes here, I got these little bearings. So these bearings, it's going to be one here and one here. So the belt comes in, goes around the pulley, and then goes back around the bearing. These things are pretty small. I think I got 10 of them. I don't know how much they were, a couple bucks, whatever. So that's kind of the plan. It's kind of going pretty good. Now that I got these finished, really going to be able to step it up now and have a visual part I can bolt some pieces to finally get this thing so I can see what's going on with it. I mean, it's one thing to look in the CAD system and this and that, but you know, when you got a physical part, it helps out a lot better. Because there's a lot of things in the CAD system that, you know, you do your best to get it right, but you know, I don't operate the CAD system. I'm actually a machinist, so I can't think of everything. But anyway, yeah, it's looking good. All right, talk to you later.